Okay, class. Let's start doing chapter 10.3, matrix representation of graph. So here we have matrices, and we have to look at the matrices from the graph. How did you end up having from the path convert to the graph, convert to the matrix? That's our goal for the chapter today. Let's check here. I advise you to do that all the time. If not, you may miss some numbers. You have 1, 2, 3. You have 1, 2, 3 vertices. If you have 1, 2, 3 vertices, you don't care about the edges. Just care about the vertices. So you have 3 of them. It's 3 by 3 matrices, okay? 3 by 3 matrix. 3 by 3 matrix. Why? Because you have 3 vertices. So you can write down like this: V1, 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 V2, V1, V3. So what does it mean? First line, first column. First line, second column. First line, third column. That's the meaning, okay? If you go to V2, V1 means second line, first column, okay? V2, V2, and you have V2, V3, and V3, V1, V3, V2, and V3, V3. Now, check here. So here we have a direct graph. This one is called direct graph. Why is called direct graph? Because we have an arrow. If it doesn't have no arrow, it won't call direct graph. Okay, we have an arrow. That's why it's called direct graph. If it doesn't have no arrow, we have edges. It's called indirect. So now we have this one. How can you convert this one in matrix? So we have from vertex one V1 to V1. It's here. It's a loop. Do we have loop on the vertices V1? Yes. It's only one loop. That's why we have to write down 1. Okay. Now V1, V2. The arrow going from V1 to V2. V1 is right here. V1 to V2. We have one arrow. We have one edges, but the edges is going to the opposite direction. This one is not. That's why we have 0 here. Because the arrow going to the opposite direction, what does it mean? The arrow means V2, V1, but here we have V1, V2, and there is no V1, V2. There is no arrow. Like there is no edge. There is edge, but there is no arrow going from the direction V1, V2. That's why it's called matrix direct graph. Okay. The next one we have V1, V3. V1 is right here, and V3. Do we have an arrow going from V1, V3? No. That's why you have to put 0. Okay. Now V2, we have V2, V1. V2 is right here, and V1 is right here. V2, V1. Do we have an arrow going V2, V1? Yes, we only have 1. Then we have to write down 1. Okay. Now V2 to V2, do we have a loop on V2, on the vertex V2? Yes. 1 loop. That's why you have to put 1 here. V2, V3, V2 and V3, we have 2 arrow, 2 vertices, no, 2 edges going to the direction of V3. That's why we have to put 2 here. V3, V1, V3, V1, we have only 1 arrow going on that direction. Okay? Going on that direction. And then we have to put 1. V3 and V2. v3, v2. We don't have no arrow here, 0. And we have a v3, 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 v3. There is no loop. That's why you have to put 0. And now we have a matrix, okay? And that matrix is called adjacency. And the notation is AIJ. And here. And remember, A and I have to go from 1 to n. Okay? Okay, let's do some more practice here. Okay, let's check this one. So here we have one of them here. Let's do that one. If you have to convert the graph, the direct graph with to a matrix, to a adjacency matrix, so we can do just as I told you. Remember, here is v1, 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 v2. You don't have to, but it's good to write down so you won't forget. And we have v1, v3, 1, 2, 3, 3 vertices. v1, v2, v1, v2, v2, and v2, v3. So now here we have a v3, v1, v3, v2, and v3, v3. Okay. Now, v1, v1, do we have a loop on v1? No, there is no loop here. Then we have to put 0 here. Okay. Second, v1 to v2, we don't have no arrow going from v1 to v2, then it's 0. v1, v3, v1, v3, there is no arrow going from v1 to v3, we have to put 0 here. Okay. v2 to v1, v2 to v1, there is no arrow going from v2 to v1, we have to put 0 here. And we have a v2 to v2. On v2 we have a loop, then it's just 1. v2, v3, v2, v3, we have 1. And v3 to v1, we have 2 of them, because we have 2 v3 to v1, we have that direction and that direction. That's why you have 2 of them. We have 2 vertices going to the same direction. That's why you have to put 2. That's the meaning. On the edge, at edge v3 to at edge v3, we have only one edge. At the vertex v3, we have only one edge going to v2. Then we have just 1 here. We have to put 1 here. And v3, v3, we don't have no loop. It's 0. Let's check. We have exactly the same thing here. You have exactly the same, this one. Just understand the process, you know how to do it. It's easy. If we try to do the second one, it will be the same way. Same way. Now since now you know, you don't have to put the v1, v2. Let's do it then just directly. First of all, you have to count how many vertices do you got. 1, 2, 3, you got 3 of them. And it's 3 by 3 matrix. And you have at v1, you have 1 loop, is 1. At v1, v2, you have only 1. And v1, v3, we have no, is 0. v2, v1, we have only 1. One edge going to v2, no, to v1. v2, v2, we don't have no loop, is 0. Now v2, v3, we have 2 edges going to vertex, no, convert to the vertex v3. We have to put 2 here. Now V3, V1, V3, V1, we don't have no edge. V3, V2, we don't have no edge. No, V3, V2, we don't have no edge. And V3, V3, we don't have no loop, is 0. It's exactly what we got here. Same thing we got here, okay? That's the way you have to do it. Okay, let's move on to the next one. Okay, the next one now you have, okay. Now this one is given, and they say draw a graph, draw a direct graph that has 8 as an adjacency matrix. So now the matrix is given. Remember the first one, they give us a graph, and we have to transform to a matrix. And this one is the opposite. They give us a matrix, and we have to make it in the graph. Okay, we have to construct in the graph. So we have a matrix here, no, a matrix, and now we have to build the graph. Let's try to do it. So now here, you have to do it like this. This one you can tell 1, 2, 3, 4. 1, 2, 3, 4 is 4 by 4 matrix. So you have here V1, V2, V3, and V4. Okay, and here you have V1, 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 V2, V1, V3, and V1, V3. No, V4. Okay, we have V2, V1, V2, V2, and we have V2, V3, V2, V4, and we have V3, V1, V3, V2, V3, 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 and V4, and V1, V1, V4, V2, V4, V3, V4, V4. Okay. Think about that one. Okay. Now on V1 is equivalent to 0. This one here. Okay. We know since V1 and V1 at the vertex 0, no, at the vertex V1, we don't have no loop. Then we just put V1 here, no loop. Okay, just put the dot here. V1, V2, we have only one edge here. V1, V2, from V1 to V2, and the direction is like this. That's the direction. Now V1, V3, V1, and V3, we have only one. It's right here. Okay. V1, V3, let's put it like this. V1, V3, make sure the arrow point to the vertex V3. We have one. Now V1, V4, we don't have no. Okay, we don't have nothing. Okay. Now the next one is V2, V1. We have only one. V2, we can write down here V2. V2 and V2 and V1, we have one. The arrow point that direction. V2, V1, we have one, and V2, V2, we have one. What does it mean? We have a loop here. We have a loop at the vertex V2. We have a loop at vertex V2. Okay. We have a loop. So V2, V3, V2, V3, we have 0. There is no connection. And V2 and V4, we have 2. What does it mean? So here, let's let's put V4 here. So we have two edges directing going in the same direction. We have a V2 and V4, V2 and V4, V2 and V4 going on that direction, okay? Pointing on V4, on the vertex V4. It points to that direction. So now V3 and V1, we have a 0. And V3 and V2, we have 0 also. But V3 and V3, we have a loop, is 1. We have a loop. We have a loop here on V3. We have a loop on V3. Okay, V3 and V3, we have a loop. Now V3 and V4, we have 1. V3 and V4, we have 1. In point that direction. V3 and V4. Now V4 and V1, we have 1. Now it's 2 of them. It's 2. So we can do it like this. Go on, turn all the way around, come back here. Is V4 and V1, we have 2 on that direction. You can also turn around like this. We can do it like this. Check. We can do it like this. You point here, you turn around, and come back here. We have at the vertex V4, we have two edges going to the direction pointing to the vertex V1. That's the meaning here. That's the meaning, okay? That's the meaning here. V1, V4 and V1, we have 2. Now V4 and V2, V4 and V2, we have V4 and V2, we have 1. So the one we can just how I can draw the one we can just draw it like this or in the middle, it doesn't matter. So we can draw it like this, okay? Here we can draw it like this because here we have V4 V2, we have 1 here. Now the rest is 0. The rest just leave it like that. So that's how the direct graph looks. Remember, the direct graph is when you have the arrow. Indirect is when you have only the edges. Okay? When you have only the edges without no direction. The direction can go both sides. Okay. That's it for this one. And you can check if you want. Is here is the same thing. Okay, same thing here. See, at V3 we have a loop, and at V2 we have a loop. Is exactly we get here V2 V3, and at V4 is right here. We have one arrow going to the opposite direction, that direction, and the arrow converge 1 2 3. We have 2 arrow converge 1 2 3 3. Yes, converge, and then one going to the vertex V2. Okay, and that's the way you have to graph. And just make sure to put V1, V2, V3 so you won't get confused. Okay, let's move on to the next one to see. Okay, the indirect now. The indirect, I think the next one is the indirect now. You have also to take in consideration about the indirect graph. Those are very important things you should know. Okay, indirect and direct graph. There are a huge difference between them. Okay. Aij is a number of edges connected to Vi and Vj. Is the same thing here. The question here, they ask you to find the adjacency matrix of the graph. Now, let's do it. You have 8 going from, now since you know 1 2 3 4, I got a 4 vertices, right? V1, V2, V3, and V4. V1, V2, V3, and V4. Okay? Now, V1, and is a loop. At V1, we don't have no loop, 0. V1, V2, we don't have no direction here. See, now we are dealing with the indirect now. There is no direction from V1 to V2, since there is no direction. So the direction can go both sides, and there is only one edge, which is adjacent, by the way, and we have only one, and we can just write down 1 here. Got it? Now V1, V3, V1, check V1 here and check V3. Is there any connection? No. That's why we have to put just 0. There is no edge. So we just have to put 0 here. Now V1, V4, V1, V4, we have 1. Let me go quick now, since you know V2 and V1. We have V2 here, and we have V1, we have 1. And V2, we have what? What does it mean? Do we have a loop at V2? Yes, we do. We have only one loop at V2, and it's just 1. Now V2, V3, we have 2 edges. We have 2 edges. There is no direction. Then what does it mean is indirect. Okay, is indirect graph. Okay, indirect graph. Okay, what does it mean? Both can go to both direction. Okay, so at V3 is right here to V1. At V3 to V1 we have 0. Okay, at V3 to V2 we have 2. At let me keep going here. I think I missed here. At V2, V1, we have 1. V2, V2, check. V2 to V2, we don't have, yes, we have 1 loop. But now V2 to V3, we have 2, okay. Now V2 to V4, we have 1, okay. Look, even there is no name, but as long as it's connected, you have 1, okay. Okay. Now V3, V1, check V3 here. Take the vertex V3 and check the vertex V1. Do we have any connection? No. Just press 0. We have 0 here. V3 to V2. V3 to V2, we have 2. V3 to V3, do we have a loop at the V3? No. 0. V3 to V4, there is no connection. There is no vertex. No, there is no edge. Then we just have to put 0. Now V4 to V1 is right here. To V1 we have 1. V4 to V2 we have 1. V4 to V3 we have no connection. V4 to V4, do we have a loop? Yes, we have 1. Okay, that's it. Now from the indirect graph, we figure out how to find the matrix. And the solution is right here. You can still check it. Just check, make sure we got the right one. We got a 0 1 0 1 1 1 2 1, and we have 0 2 0 0 and 1 2. Yes, very good. Now one thing I want to point out before we move on is this one. Look at here. Be careful. It will come on your exam or your exercise. If you check the graph, if you look at the graph, okay? If you look at the graph, you know from V4 to V1, there is only one line, and don't ever think even the line is not notate. Even there is they didn't notate. It's still an edge, okay? As long as they are connected, it is. You have to put 1. It's the number of connection. That's the number you have to put. It is only one connection between B4 and V1, or V1 to V4. That's the why it's called indirect, because it can go to both way. Check. Let me give you one example. Check here. V4 to V2 equal to 1, and this one also is equal to V2 to V1. Let me anticipate a little bit. Check here. You have V4 and V1 is 1, is here, and you have V2 is here, and V4 is here, is still 1. This one, let me anticipate a little bit, is not big. I don't think so I have to teach you this one, but this one is called commutative, okay? Commutative, when you study in group, in algebra, it's called commutative. But since we didn't study yet that, so just stay there for now. And that's it, okay? And now the symmetric. Let me talk to you about the symmetric. Symmetric, I think you already know that because you took linear algebra. Symmetric is, if you have a matrix, is symmetric if I and j, from I and j grown from 1 to a, and then a I j is equal to a j I. Let's give one example here. Let me give you one example here. Okay, if you have aij is equal to AJI, what does it mean? I has to be equal to j, and j has to be equal to I. You can switch it. You can change it, okay? If you check from here to here, you can move this one up, and you can move this one down, okay? It's symmetric. Got it? You can also take this one and move it down, and you can take this one and move it up. That's why I call symmetric. Okay, let's move on. Symmetry, I think I will give you some exercise so you can understand. I know you do, it's just to make sure. Okay. Matrix and connected component. Here, if you check that graph, they are not connected here, okay? They are not. They are separate. But still, we can build a matrix. Okay, since you know how to graph, first things you have to do, you have to count how many vertices do we got. 1, 2, 3, 4, 5, 6, 7. We got 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's the first things you have to know. It's 7 by 7 matrix. Okay, now from here, just let me point out some here. This one is fine because this one is much more faster. At the vertices 1, at the vertex 1, we have a loop. Then that's why we write down 1 here. 1. We have a loop here. That's why we write down 1. Now, at the vertex also, V1 and V3, V1 is here and V3 here, we have only one edge. If you check this one is indirect. You can tell it's indirect because there is no arrow. It's indirect. And so on, keep going because you have so many 0, because there is no connection between. Listen to me. Let me draw in red. There is no connection between this one. No connection, 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 no connection. There is no connection. The red I do, that's why you have so many zero here, okay? And those are called black. And on the black, you can have a symmetric. It can be symmetric. Check here. If you check that black, you take this one and you move it, and take this one, move it up. It's symmetric. Okay? It's called black. I don't have to teach you that. I know you know. I know you know because you took linear algebra. All those is just linear algebra. This one, I don't have to teach you this one. This one is basic. You learn linear algebra. You just have to multiply. Just take the dot, okay? Just take the dot, and this one is just think about is if you have a vector, if you have a vector v1, for example, v2, v3, and you have another vector w, which is let's call it a w1, w2, w3, okay? If you have to multiply w and v, that's what we get. It's just a dot product. Just take the dot product and add them, and you have a scalar. If you take the dot product for this one, you have v1 w1 plus v2 w2 plus v3 w3, and that's it. And you will have a scalar, okay? Now next, I think it's just multiplication matrices, and yeah, those, you know it. You know how to multiply matrices, add them, extra, keep going. Okay, I don't have to teach you this one also, and I know you know it. Just a matter of fact, let me go over with you. So if you have to multiply that matrix to this one, take this one times this one, what do you get? You will get 8. 2 times 4 is 8, and 2 times 0 is 0, and 3 times -2 is -6. Okay, be careful here, by the way. Be very careful. You see that one? It belongs only to this one. You have to be very careful. Okay, just let me point out something. Let's do this one. So if you have to calculate this one, you take this one times this one. It's called like just I did right now. You just have to use the dot product, and you have here 8, and here is 0, and here is -6, and you have 2, and write down 2 here. Okay, take this one, same thing, times this one. Okay, and what you have, 6 times plus 0 and -3, and you have 3. Write down 3 here. Got it? The next one, do the same tactic. Take this one times that vector. Remember, it's a dot product. It's -4 plus 2 plus 0. And you will have a -2. Okay? The next one, do the same thing. This one times that vector. And you have the dot product, -3. And you have plus 2. And you have plus 0. And you have -1. This is exactly what you get. So now you can tell C1 is 2, C2 is 3, C2 and CN1 is just -2, and C2 is -1. That's it. That's the way you have to do it on here. I don't know if they got it here. It's a long process. They do it here. I just summarizing directly here. I think they got the same thing here. They got a 2, 3, -2. Okay, I advise you to not use this one. Just use the way I told you. I think it's the same thing. I think it's the same. Yeah, it's fine. It's just a long process. They try to do it. Okay. Next. Okay, let's move on. Let me stop here. Identity, I will go over when we do some exercise. And does, I know you know it because you took linear algebra again. I have to repeat it so many times. And you know how to find the identity. Okay, I know you know it. Let me just jump on. Yeah, let me just jump on the exercise so we can start doing. Let me stop here because the video is too long.